Okay, boys and girls, good afternoon. We're going to continue our conversation about additive versus multiplicative relationships. We're also going to be talking about independent and dependent variables and the relationships with them as well. Okay, so we're going to look at these rectangles that we have down here, and we're going to look at the width and the length. Okay, now our width is going to represent our x, and our length is going to represent our y. Okay, so our width is our length, and our width is our x, and our length is, so the width of this rectangle is 1, and the length of this rectangle is 3. So this is a 1 by 3 rectangle. Okay, so when looking at the next rectangle, the width is 2, and the length is 4. Our next rectangle, the width is 3, the length is 5. Now noticing as we're going, our width is increasing by 1, and our length is also increasing. So looking at those relationships. And our last one, our width is 4, and our length is 6. Once again, increasing by 1 for each one of those. Now remember our acronym, DRY mix. DRY stands for the D is dependent variable, and it responds to the independent variable. So R is for responsive, and then the Y means that it's located on the Y axis. Okay, so that is our Y. That is our dependent variable. So I'm going to record that right there. Now the independent variable is the one that we manipulate. It's the one that is also located on the independent axis, on the x-axis, excuse me. It's the independent one that's on the x-axis. All right, so remember, the independent variable determines your dependent variable, okay? So the width is 1, okay, on the first one, and the length is 3. Go ahead and scratch that out, what it says sketch. We're not going to draw it again. We're just going to write what did we do to the 1 to get to the 3. So the 1, which is your width, increased by 2 in order to get to 3. The second rectangle, we increased by 2 again to get to the 4. The third rectangle, we increased by 2 again to get to the 5. And the fourth rectangle, we increased by 2 to get to 6. So if I had a fifth rectangle, okay, so that means that the width would be 5, and we said each one is increasing by 1, so this would be 7. What plus 5 gives me 7? Well, once again, it's increasing by 2. So if you'll notice this pattern right here, each time it is increasing by 2. You're adding 2 each time. So what would be my equation that would represent this so that I could plug in any number I want for the variable? So we're going to obviously start off with our x. Okay, our width here is our x. And what are we doing to x to get to our y? Well, we're adding 2 each time. Okay, so that is our equation that we would plug in for this situation to make whatever rectangle we wanted. Now, let's look at our graph. Notice our graph is we're counting by 2's to the right and 2's up. Now, we don't have any negative numbers, so we won't be using the negatives. Okay. All right, so I'm going to graph these now. So the first one is graph is 1 graphing 3. So I'm going to go over 1 up to 3. Next one is 2, 4. So I'm going to go over 2 up to 4. The next one is 3, 5. Then we have 4, 6. And I know it's a little hard to see those lines. They didn't come through on the copier. 7. Then the last one is 5, 7. Now we're going to take our ruler and we're going to connect those dots together. Okay. And notice that the line does not go through the origin. Now remember, if it does not go through the origin, which most additive ones do not go through the origin unless you're adding 0 to 0, okay? That means it is a non-proportional linear equation. Non-proportional linear equation, okay? So it's non-proportional. Remember, these are all linear equations because these tables create a line. See the word line and linear, okay? Now it says, based on your graph, if you were to continue the pattern, what order pair represents the length of a rectangle with a width of 0? So if I plug in 0, okay, for the width, I'm going to add 2 to it. So 0 plus 2 would be 2, okay? Does the order pair make sense in this situation? No, because why? Well, remember we just talked about it's non-proportional, okay? Because it would not be a line, okay? So if we did 0, okay, and then we did 2. It says, based on the graph, if you were to continue the pattern, what order pair would it be? Does this pair make sense in this situation? Okay, number 1, 0, you can't make a rectangle with 0, can you? So no, because it would not be a line, and I meant not be a rectangle, excuse me. It would not be a rectangle. You cannot make a rectangle with a width of 0. Okay? Number 5 says, write an equation that would be used to determine y, the length of the rectangle, given x, the width of the rectangle in this family. So basically, y would equal, and all they're asking you to do is write the equation that we have up here. So y equals x plus 2. Remember, y is your dependent variable, and it's determined by your independent variable, which is your x. Okay? All right, next page. Multiplicative. This is an example of your multiplicative relationship. So I want you to write multiplicative at the top. Okay, this time, all right, we have our rectangles are reversed, okay? We have the rectangles going up and down. So this time, our width would be 1, here's our width, and our length would be 2. Okay, I want you to continue on. Width would be 2, and the length would be 4. Width would be 3, length would be 6. I want you to continue on with this page. I want you to pause the video, and I want to see how you do with the rest of the video compared to what we did with the other one. Okay, so go ahead, pause your video now. All right, boys and girls, I'm back. I hope you've completed this page. I'm going to show you the example of what it should look like when you are done. Okay, so over here, your width you have is 1 and your length was 2. So each time it increased by multiplying by 2. So that's why it's a multiplicative relationship. Also, it went, when you graphed it, it should have gone through the 0, 0, which makes it a proportional linear equation. Okay, number 3, you should have gotten 0, 0. Okay, and once again, no, because you cannot make a rectangle or a square or a rectangle from 0. All right, then your last question, y equals 2x would be your final, because remember, your dependent variable is determined by your independent variable and what you do to it. So y equals 2x. All right, I hope you have a great rest of the weekend, boys and girls. Thank you for doing this extra work for me, and we'll see you later.